Alright, so we are on your notes, your page 24. If y'all didn't get the rest of the back of this, if you don't have all that yet, it is okay, we'll get it. And our TEK is 12B today. So, if you didn't get all that, don't worry about it, we'll get that at another time. Alright, so we are doing some graphing today, actually a lot of graphing today. So yesterday, we looked at a couple of these a little bit, and we kind of gave you some overall about some different graphs. So if we look at this first box up here, 2x, you should be familiar with that graph. What kind of graph is that going to be like? What's it going to look like? Well, constant would be a horizontal line. What's that? Yeah, it's going to be a straight line. It is a linear graph. Is everybody okay with that? Like, it is a linear graph. So linear meaning it's a straight line. So, y'all should be familiar with that. Technically it is in the form y equals mx plus b, but there is no b, which means the b value here would be what? It would be 0. Everybody okay there? Alright. It's gonna have a slope of what? 2. It has a slope of 2, so it's steeper than your standard line, right? Everybody okay there? Alright, so we kind of know what it is. This one, and we're going to come back to this description in just a second. So let's go to B. Let's take a look at it. So I want you to look at A in comparison to B. What is different about these two things? The x is being squared. So over here, x has a power of what?
2.
No, in the first one.
Oh.
X has a power of 1 in the linear graph. Everybody okay there? Which is what y'all are used to. So in a linear graph, x has a power of 1. When we get over here in this second graph, y'all just said x is squared, or x has the power of 2. So I'm going to pretty much write that. The x is squared. So that's what's a little bit different from that one. We looked at a couple of these graphs yesterday. Does anybody remember what that graph will look like, just in general? Because it's not a straight line. You remember what it looks like? Yeah, it's a curve. It makes like a U shape. That's generally what it looks like. So the graph makes a U, and I'm going to do it like this, a U shape. We typically call it a U. It has a special name. I'm not worried about you knowing that right now. The other thing about this, and y'all probably couldn't see it a whole lot in just the examples that we had yesterday, although one of them, the one like on the left in your notes, you probably can see it. These graphs are symmetrical. What does that mean when I say symmetrical?
They're the same on both sides.
Yeah, it's the same on both sides. So when we make that U, when we look right here, like this point right here would be considered the vertex. Y'all should be familiar with the word vertex. So at the vertex, that graph is cut in half, and the left side and the right side look exactly the same. And again, like, you don't have to know a bunch about these graphs right now, these other two, because we're going to get to those later in the school year, but it kind of helps just to have a general idea. So I just need you to, in general, kind of know what a graph's going to look like. You don't have to know any details, but just that. All right, so when we look at this one over here, and y'all haven't seen this one yet, what do you notice about this one, this equation? How's it different?
It doesn't
It's-
know what the two's being squared with that.
Okay, so if the 2's not being squared, what's happening with the 2?
It's being squared.
It's being taken to some x power, right? Because in every problem, x is our unknown, right? Like, it's something that we don't know what it is. In this case, our unknown is in the spot of the exponent. Is everybody okay there? Does that make sense to y'all? Okay, so this time x is in the exponent spot, location, whatever. Okay, so I want you to think about this when we talk about, and 2 is a really good number to use. This is the one we use the most often with these types of functions. So this is called an exponential function because x is in the exponent spot. That's why it's called that. Okay, so if you think about that like here, if I take 2 and I take it to the first power, it's 2, right? If I take 2 to the second power, what do I get? 4. If I take 2 to the third power, I'm going to multiply times 2 again, so I'm going to get 4 times 2 is 8. If I do it again, I would get 8 times 2 is
16.
16. If I do it again, I'm gonna get 32, and then I'm gonna get 64, and then I'm gonna get 128, and it keeps getting bigger. So what we notice about that as we look at those numbers, whereas like in a linear function, it's going up by the same amount every single time, right? It's going up 2, up 2, up 2. But with an exponential, that's not happening that way because that exponent makes it go up super fast. Does that make sense? So it grows really fast in general. So that's kind of what I'm gonna write there, is it grows really fast. And so the overall general shape of this graph, and we're about to look at them here in just a second, is something like this. And of course it can vary at some, but that is the overall general shape. And you'll hear me use a term a lot during the school year is what I say is the parent function. The parent function is like the original function. So for a linear, the original function is y equals x, where it goes through the origin and it has a slope of 1. That's the parent function. Everything else is related to that one. It means I take the parent function and I do something to it. The same, this is the parent function of the quadratic. Every other quadratic is based off of that one. This is the function that we use for the exponential. I can't use 1 as the base because 1 to any power is still going to be 1, so we never can use 1. So we generally use 2 as the base function. So just so y'all can kind of understand some terminology there. All right, so here, this is kind of like when we looked at it yesterday when we first talked about, like the little function machine, and it's like we're going to put the numbers in and we're going to get the output. Everybody okay there? So when they're saying process, they're saying what am I doing? So these are my x values. F of x is the same thing as what? The y value. So this is our output, right? Okay, so these are my inputs, and I'm going to put them into this function. So here, I'm going to have 2 times, and in place of x, I'm going to put negative 2. And here I'm going to do 2 times negative 1. And here I'm going to do 2 times 0. I'm going to do that all the way down. I'm going to go ahead and write them in. Alright, so if we do that, and we're going to evaluate the function at those numbers, which is what we did yesterday. I have 2 times negative 2. What's 2 times negative 2? Negative 4. 2 times negative 1. Negative 2. 2 times 0 is 0. 2 times 1 is 2. And 2 times 2 is 4. Okay, so I'm going to go down here, and I'm going to take these ordered pairs, and I'm going to put them on my graph down here. So I'm going to do them in the same order. So I have negative 2, and I go down to negative 4 down here, and then I had negative 1, and negative 2, 0 and 0, 1 and 2, and 2 and 4. One thing you need to be really careful of is when graphs are labeled, make sure that we know what those labels are. So I'm going to talk to you about yesterday's assignment a little bit tomorrow. Okay, so that's what my graph looks like. Right, pretty much what we expected it to look like, right? Okay, so if we go over here and we do this one, same thing, we're going to do our process. So negative 2 is the input, so I have negative 2 squared. Why does that need a parentheses around it?
Because it's negative.
Good, so I make sure that I get that. Some of y'all yesterday, like you didn't put parentheses around things and it messed you up. Okay, so when I do negative 2 and I square it, I'm going to get what? I'm going to get positive 4 because that's 2 negatives are going to give me a positive. Negative 1 squared is going to give me positive 1. 0 squared is going to be 0. 1 squared is 1. And 2 squared is 4. So if I go put these on here, negative 2 is at positive 4. Negative 1 is at positive 2. 0 and 0. 1 and 2. 2 and 4. Alright, so I know you would really like to make this a V. It is not a V. Okay, it needs to be curved down here at the bottom. And your graphs do not have to be perfect, but it needs to be distinctly curved and not a V, because a V is a totally different type of function. So we make sure that if we draw that as a V, you're drawing a different function. And so it is absolutely curved. Alright, does it look like what we thought it was going to look like? Yes. So on this, you notice like the vertex sits on the axis line. When that happens, we love that. Because when it sits on the axis line, then -1 and +1 are the same, and -2 and +2 are the same, and -3 and +3 will be the same, and so on. Does that make sense? When that graph is shifted to the left or right, that won't be true. It'll still be symmetrical, but those numbers at 1 and -1 aren't gonna match when I move that vertex over. Is everybody okay with that? Does that make sense to y'all? Still gonna be symmetrical around that vertex, but it would be shifted over, so those numbers wouldn't match up. Alright, so now we're gonna look at this other one. So I'm doing the same thing, I've got 2 to the x. So I have 2 to the -2, I have 2 to the -1, 2 to the 0, 2 to the 1, 2 to the second. Okay, without a calculator, I want us to kind of think through this. So we talked about a while ago, when I took 2 to the second power, it gave me 4, 2 to the third power gave me 8, 2 to the fourth power gave me 16, and so on. So those numbers are getting bigger and bigger and bigger and bigger, right? Okay, so if taking it to a positive power makes my number get bigger, what do you think it's going to do when I take it to a negative power? It's going to get smaller. So, and we will cover exponential laws and rules later, but basically the gist is we're not allowed to use negative exponents. So in order to make an exponent positive, I basically take whatever it's attached to, so in this case the base is 2, I take that number and I put it in the bottom of a fraction. So I basically kind of take its reciprocal, I move it to the bottom. And of course, since there's nothing in the top, we would write it as 1. Does that make sense? So then when I move that, anytime I do that and I move across that fraction bar, it changes the sign of the exponent. It does not change the sign of the number of the base. The base stays the same. So it's still positive 2. But when I move that to the bottom, it makes it 2 to the 4th. We already know 2 to the 4th is, 2 to the second. So we already know 2 to the second is 4, right? So now it is 1 over 4. Does that make sense? And so if I took it to the third, to the -3, it would be 1 over 8, and then 1 over 16, and 1 over 32. So it's going to continue to get smaller and smaller and smaller and smaller and smaller. It doesn't become negative necessarily, it just gets smaller. Everybody okay with that? So, and we'll look at it on your calculator in a little bit, and you'll kind of see what happens. But that's how that's going to work. So we just talked about it. This is 1/4. Now I am going to make sure y'all do know how to put that in your calculator. Does everybody in here know how to get an exponent in the calculator? Everybody knows where to go to do that? Yes? Yes? Okay, alright, just want to make sure. Alright, so that would be 1/4. This one, so this I already know. This is 4. 2 to the first is 2. Anything to the 0 power is going to be what?
0.
Not 0.
The number.
It's going to be 1. Anything to the 0 power is 1. Try it. Put it in your calculator. Do 2 to the 0. It's going to give you 1. You can put 9,532 to the 0 power. It is still going to give you 1. Anything, even x to the 0 power, is still 1. Everybody okay there? That is never going to change. Alright, so if we look at this right here, what is 2 to the -1 going to be? Without your calculator, what is it going to be? Use some logic. Not going to be -2. It's going to be 1/2. Because it's the same thing as 2 to the first, but I got to take the reciprocal because of the negative. Does that make sense? Alright, so those are our values. So we're going to go put them on our graph down here. So when x is -2, I'm at 1/4, which is about right there. When x is -1, I'm at 1/2 right here. When x is 0, I'm at 1. When x is 1, I get 2. And when x is 2, I get 4. And since it'll fit on here, when x was 3, it would be at 8. So I'm going to go ahead and do that one right there. Which means 2 to the -3 would be 1 over 8, even closer to this line right here. Does that make sense, to the axis line? It never crosses the axis line. So if you have to sketch one of these graphs, do not draw it where it crosses that axis line, because it does not. It's wrong. Make sure also when you draw a graph that you put arrows on the end, because if you don't put arrows on the end, that means something different, and it's got to have it. Everybody okay there? Alright, So then it asks a couple of questions down here. The first thing it talks about going back and adding stuff to our table up there. We're not gonna do that, we filled that out already. Alright, so this question down here, number 2, says, do the graphs support that each relation is a function? So, do all of these qualify as a function? Okay, what's the easiest way to check when I have a graph? Vertical line test, and it passes, right? Everybody okay there? So she said yes. We'll say yes. Okay. They pass. However you want to write this. That VLT. And if you remember VLT means vertical line test, then write VLT. If you don't remember that means vertical line test, then you probably need to write that out so that you know what that's talking about. Because if you write it on there and that doesn't mean anything to you, then your notes don't help you. So make sure you're writing things that mean something to you. Alright, and so this says, so this kind of goes back to yesterday. So it says, describe how you can evaluate f of 2 and g of 2 by only looking at the graph, because we had to do that yesterday. So f of 2 goes to this one, right, because that's the f function. G of 2 goes to this one right here. Now, of course, we already know what they are, but when it says evaluate f of 2, and I'm only using the graph, what are they actually asking me to do there? What are they saying there? What are they asking me to do if they said, what is f of 2?
They want you to solve for x being 2.
But I don't have the equation. All I have is a graph. I don't have any of, if I had none of this right here, and all I had was this graph right here, what are they asking me when they say, what is f of 2?
You would look at the 2 and see where the other, when y is 2, what is x? When x is 2, what is y?
Yep, when x is 2, because remember, the number that's inside that little parentheses, remember, I have f of x, right? So they're saying, what is f, or what is f of x, what is y, when x is 2? So they're asking me to find y when x equals 2. So that means I'm going over there and I'm going to go over to 2 on my graph, and I'm going to go up and I'm going to find what the y value is. And the same thing in the g function. I'm going to go over to 2 and I'm going to go up there and I'm going to find what the y value is. Everybody okay with that? Like, it is really, really important that you understand what they're asking you right here, and that we're clear on what they're saying there. Everybody good? I mean, if you have the equation, it's great because you can plug it in, but if you don't and all you have is a graph, you have to know what they're asking you to find. Everybody okay? Alright, so now we're about to get to the calculator. Alright, and I don't know how comfortable you are. I asked the other class if y'all did very much graphing. They said y'all did some, but y'all didn't do a ton last year. Is that a fair assessment? Okay, you're going to do a ton of graphing in here. So we need to be proficient with that calculator. Okay? So, if I need to put my equation in the calculator and graph it and see what it looks like, what is the first button that I push? Do y'all know? I do not hit graph. Anybody know where I've got to put the function in? Anybody know where I do that? Y'all remember? Okay. First thing I'm going to do is I'm going to go up there and I'm going to hit y equals. It's in the top left corner. Does everybody see it on your calculator? Right here. All of these buttons right here have to do with graphing. Okay? So I'm going to hit y equals. So in your calculator, do that. We're going to do this first problem. So when you hit y equals, you should get something that looks like this. You should have a whole list of y equals. I can graph a whole bunch of functions all at the same time. Everybody okay there? Okay, so you should have this. Then what I'm going to do is in that y equals, I'm going to enter the function. And remember, function is just a fancy word for equation. So I'm going to enter the function. So in this case, my function is x plus 5. Does everybody know where the x is? Yes, no? Okay, if you don't, it's right here. It's next to the green button. And it does not matter what variable our problem has. You know, yesterday we had like h of t and g of s and all these different whatever. It doesn't matter because we're going to write, our calculator is going to use x every single time. Okay? So we're going to do x plus 5. We type it in. That's what we just said. Enter the function, right? We did that. Then hit graph. And it's going to graph it for you. So those are your steps to get it into the calculator to look at the function. Everybody okay there? Does everybody's graph look like that? Okay, if something happens and you put it in and your graph doesn't do what you think it should, I mean, because in general, like, you need to have a general idea of what a function should look like. Because if you don't know what it should look like, you don't know if it's doing it right. Okay, so you should have a general idea. All right, so if you get this in there, because we ran into this in my last class, if you put it in and it doesn't do what it's supposed to, first go back to your equation and make sure you put an X in there in the right spot. Check that first. If you did that and your calculator still does something crazy, somebody's this morning gave him an error, wouldn't graph it at all. Somebody else this morning, like, their window was all messed up. So the first thing that you do when you have that kind of an issue is reset your calculator. And if you don't know how to reset your calculator, you need to make sure that you learn how to do that. It's 2nd plus 712. You should know how to do that because you should have been taught that last year. And you have to clear a calculator before you take any test in my room. So make sure you know how to clear that calculator. 2nd plus 712. Clears it every single time. What that also does is it resets everything in the graph back to the normal window. The normal window is from -10 to +10 on both the x-axis and the y-axis. So I had somebody this morning whose window was all messed up. What happens is, and I wasn't like being ugly, but what happens when y'all mess around with things in your calculator and you don't know what you're doing, you mess it up and then it doesn't do things that it's supposed to do. So, like, I'm assuming that's what happened. And by mess it up, it's not permanent, but I mean, it takes some fixing. But 2nd plus 712 will reset everything to the standard, the normal settings. Everybody okay there? Yes? Okay. So the next thing that this talks about is, how do you find a table of ordered pairs? I can go find every single ordered pair on that graph if I want to. Okay? It makes my life easy. So in order to do that, you're going to hit the second button. That second button is blue. When you hit that blue button, that means you have now switched from the primary functions, which are the main things on the buttons, to everything that's in blue. Does that make sense? Just like if you hit the green button that's alpha, you switch to everything that's in green. Everybody okay with that? Which is kind of hard to see on the screen. But that's what happens there. Is everybody okay? Yes? Okay. Alright, so I hit the second button. Then I'm going to hit the graph button, because if you look right above the button that says graph, in blue it says table. So when you hit that, now it gives you this. This is a list of ordered pairs that are on that graph. Did y'all know that was there? Okay. Alright. So that gives, and it doesn't give me every value of x, it gives me all the integer values of x. So it's not going to give me fractions, it's only going to give me whole integer values of x. Everybody okay there? Yes? Okay, so I'm going to kind of jump down here for a second and then I'll come back to this. So right here, it's the first thing it says evaluate f of -10. Well, I can plug in -10 to my problem and do that, right? That's what we did yesterday. I can also go to my calculator and get it right here out of this table. So I can go up to -10 right there, and it's -5. So f of -10 is -5. I didn't have to do any work. Alright, now sometimes I'll make you do work, but in this case, we don't have to. Alright, now that's not going to fit on this graph. My paper graph is -8 to +8. It's not -10 to +10. I counted them earlier. So that point isn't going to fit on there. But it asks me to list 3 ordered pairs. So from -8 to +8, x values, that's where I'm looking. Give me an x value on the negative side, somebody. -2 and what? What's its y value?
-7.
-2 and -7 is not what mine shows.
Oh, my x is -7.
Okay, so when x is -2, I've got y is 3. Okay, so -2, +3. Got that. Alright, I know the y-intercept because they gave, like, I have it, I already know what it is. It's 0 and 5, right? Which is also on my table. So 0 and 5 is up there. Alright, so let's find another point over, we already know it's going this way. So let's find another point over here somewhere. So, what did you say, Tori, a while ago? -7?
And -2.
-7, -2. Alright, so -7, -2. I found 3 points. So that's going to be right here. Alright, I think -5 was at 0. I'm going to go ahead and put it on there just so I have a few more points. Alright, 3 points is usually pretty sufficient. So my graph looks something like that. And it's accurate because I got points out of that table. Everybody okay there? Yes? Okay, so the last little part of this up here, it says, basically, what if I wanted to see something closer on my graph? I can tell you this, I rarely ever want you to do this because then it changes your window and then you have to go reset things, alright? So what I'm gonna show you to do is if you hit that button up there that says zoom in the center, there's a whole list of options there. Y'all really should not need this, really hardly ever in Algebra 1. But if you wanted to zoom in or zoom out, it's right here. Problem is now you've changed your screen and it looks different. So if I hit zoom in, you see that this is like blinking right here. Do y'all see that? It's gonna zoom in with that and it's gonna recenter my graph, but it's zoomed in. Now I can't see the graph at all, right? Because it's outside of my window, because now my window is basically -2.5 to +2.5, and none of my points fit that. Does that make sense? So typically, I don't like you to zoom in and out on your graph. Occasionally, you might need to, but it's rare. Okay? So, how do we fix that and get it back without having to reset our whole calculator? So if you go back to your zoom, right here, number 6 says zoom standard. Okay, and that gets you to the what I call normal screen, or the normal window. Now there are other ways to adjust that window. I really don't want you adjusting the window. I mean, sometimes we have to do it more like an Algebra 2 recal. Y'all shouldn't really need to adjust your window. Again, it throws everything off and things have to be reset. Alright, so those are kind of your basic, how do I do stuff. Alright, so let's go to number 2. The first thing I need to do is graph it. So to graph it, I'm going to hit what button? I'm going to hit y equals. Now my other equation is still in there. So I need to clear that. So right here, there's your clear button. So hit clear, and it takes it out. You see this button right here, that DEL? That is delete. Don't use that button, because if you delete something, it can mess lots of things up. So don't use that button. Okay. All right. So now back to this. My function. Before you type this in, we already know what positive x squared looks like, right? What do you think negative x squared looks like? What is a negative in front of my function gonna make it do? Say it again.
Like an A, but without.
Yeah, it's gonna flip it over, it's gonna make it go down. Does that make sense? So let's see if it looks what it's supposed to. So we've got negative, make sure you use the negative sign and not the subtraction. So we've got negative, and then your squared button, you all know where that is right here. You can use the square, you can use the caret, but for squared, I usually use that one, it's faster. Alright, we got it in there. Then we hit what? We hit graph. Alright, everybody's here except Maddie, right? You missing anybody else? Kaylee's not here. Y'all ain't seen her today? Okay, so did it do that? Is that what yours did? Okay, so I need to go get some points. They want me to evaluate f of 5, which again, I can take that down and plug it in, right? So 5 squared is what? 5 squared is 25, but there's a negative out front, so that really means the opposite of that. So I actually get negative 25 right there. If I go over to my table and I go to 5, it says negative 25. It's exactly what I calculated it to be. Are we okay there? They gave it to me. Alright, that is not going to fit on my graph. So I've got to find some points that are going to fit on my graph. So give me a point on the negatives. Well, 0, 0 is obviously there, so we can write that one down. Alright, so give me a point on the left side that'll fit. What can I graph there?
-2,
-2. -2, -4. Which means I can also graph +2, -4, because it's symmetrical. -1 is at, so we did -2, -4. Where is +1? +1's at -1. Okay, right there. So we should look something like that. Are we okay there? 3 and -3 would both be at -9. Are we okay with that? 4 and -4 would both be at -16. Alright, because that pattern is gonna continue, so it's gonna look like an upside down U, which is what y'all said it should look like, and it does. Everybody okay with that one? Alright, this one. So this is what kind of function would we call it? Y'all remember? I'm gonna write that over here. This one right here is quadratic. This one right here is called exponential. And it's exponential because x is in the exponent spot. Alright, so we knew what this one looked like, right? Yes? Okay there? Alright, so what is this one you think gonna do? Okay, so what happened with x squared when I put a negative in front of it? What happened to it? What happened? It flipped, right? It flipped over. Same thing happens with the linear. It has a positive slope. When I make it negative, it flips over and has a negative slope, right? It's like it's a reflection, which y'all did reflections last year. Alright, so this is basically gonna be a reflection. So instead of going up, we're saying it should come down. Let's see if that's what it does. Now, before we do that, I want you to look at this. They're saying f of 0. What's gonna happen when I put a 0 in there? It's gonna make it 1. Everybody okay there? Yes, no? Alright, so go to your y equals and put it in there. I've got -1.5, right? For the x? Yeah, -1.5. And graph it. Did it do? Oh, that should be a -1. Yeah, sorry. The negative was out front. Sorry, yeah, the negative was out front. Okay, so does it do what you think it was gonna do? That's gonna be a -1 because of the negative out front. This becomes 1, but the negative's there. So did your graph do this? Did it flip over and do that?
When we do the -1.5, how do we do
Okay, to put the x in there, alright, so we go to y equals, this is your exponent button right here. That little button right there. So, because we use the squared a lot, but if I need something besides a square and I need an exponent, I use this button right here. So after you put in your -1.5, hit this button, then it'll put your little cursor, it'll be blinking up here, and you can hit the X button, and then hit enter. Did y'all get that? Okay, so make sure your graph should look like that. Does our graph look like that? Everybody okay? Did you find it, Tori?
I think, but it's not going.
Okay, now graph it. You're good. It gave it to you. It's up here.
Oh.
You're good. Okay. Alright, so I'm gonna go over here and look at my table. Alright, so we have f of 0 is -1. This is not gonna have nice points. It's a lot of decimals because I had -1.5. So of course it's gonna be a lot of decimals. Alright, so there's not a ton of options. I am gonna write the -1 because I need something on that left side. So I'm gonna write -1 and I'm gonna write that point as -0.6, and I'm gonna write it with the repeating so that I don't have to write all that decimal out. Are y'all okay there? Yes? Alright, so when I put that on my graph, here's -1 and -0.6, I don't know, about halfway, somewhere in there. It's not gonna be perfect. 0 is at -1, so I already got that one. Alright, so if I go to +1, it's where? What does your calculator say at +1? -1.5, that one's relatively easy to graph. So +1, -1.5, about right there. Alright, at 2, I am at, what's your calculator say?
2 and
Negative 2.25. That one's relatively decent to graph. It's not gonna be perfect. Here's negative 2, negative 2.5, just a little bit more, right? Something like that. Are we okay there? Everybody good? None of those other points are very nice. If I look at 4, it's like 5.063. You'll see that? So if I go over here to 4, 1, 2, 3, 4, and I'm gonna go down 1, 2, 3, 4, 5, and I'm just barely like I'm pretty much at that line. So that gives me a general idea what this looks like. So it's pretty flat right here, and then it curves and comes down to something like that. Remember, this doesn't cross that axis line. If you go in the negative side of that calculator and you scroll up there in your table, these numbers are just gonna get to be smaller and smaller and smaller and smaller and smaller negative decimals. They are never, ever, ever, ever gonna go above, get to 0. Okay, they're not gonna cross that line. We'll talk about that later in the year. Alright, everybody okay with that one? Alright, let's take a look at this one. What kind of graph are we gonna have here? Look at the equation. Like, what type of graph is it? So it's gonna be linear. Okay, so it is a linear, it's in slope-intercept form, it's gonna be a linear graph, it's gonna be a straight line. We know that's what it should do, right? Alright, so go back to y equals, hit clear, put your equation in there. Overall, what should this graph do? In general, we know it's a straight line, what else should you know just by looking at the equation?
It won't stop. It'll go down.
Yeah, oh, and is that 3.5 there? If I stop 35 anymore. You need to always look right here. You need to always know, is your graph going up or is it going down? That is something you need to always look for every time you look at an equation. Okay? 1, identify what type of equation it is, and 2, identify is it gonna go up or is it gonna go down? Does that make sense? Those are kind of like the 2 things that it's really important, because here's the deal, you may accidentally type it in your calculator wrong, and if you don't have a general idea in your mind of what that graph should look like, you write down totally wrong stuff because you don't know what it's supposed to look like. So in general, we need to know what type of graph it is, and is it going up, is it going down? Does that make sense? That way, when I graph it and I look at it, I can look at that and say, yes, that makes sense based on the type of equation that I have. Everybody okay there? Yes? Yes?
Yes.
Okay. Alright, they're asking us for f of 6. So where am I going to get that?
Table.
Your table.
I'm going to the table. So what is f of 6?
Negative 6.5.
Negative 6.5. Alright, so I'm gonna go ahead and put that one on there. 6 would be here, 6.5, 1, 2, 3, 4, 5, 6, and part of the way. Right there. Alright, so somewhere around in there. Alright, they want 3 other points, so let's work our way back this direction. So find me a point somewhere in here. Weston, pick me a point somewhere over in here. Still positive x value, but somewhere over in here.
Still within that specific.
Yeah, give me a positive x value.
Okay, 1, 2, I guess.
1 and 2.
Yes.
I've got 1 and negative 4 on my table.
Oh. Well, I don't really. Unless you want a specific answer, or we're just anything.
No, but if your 1 isn't at negative 4, I need to check and see if we have something wrong in your graph.
Oh, I haven't.
Oh, go over here to your table.
Yeah.
Yeah, go back to your graph. Hit graph again.
Okay.
Alright, go to your table. Now, that's what I was asking for.
I see. Thank you.
Okay, so I got 1 and, do y'all have 1 and negative 4? Because you don't have an x in here.
So I see.
So you need to retype your equation in there. Retype that equation in there, because you don't have an x. Anytime, like, here's what happens, Claire, with that, like, if we don't have an x in that equation, it's always gonna graph it as a horizontal line, because it's gonna calculate out whatever that is, order of operations, and give you a horizontal line. Because y equals some number, straight line, always. So anytime that happens to you, that means you missed the x somewhere. Alright, somebody else, we got 1 and negative 4, right, now what we had? Okay, where is it at 0? Negative 3.5, right? Because that was the y-intercept. Alright, give me a point on the negative side. Maybe -2 or 3, where it's an integer value. Which one? Casey, give me one. -2 or 3, one of those. It's nice number.
-2.
Okay, so -3 and -2. Is that what you got? Yes?
Yes, ma'am.
Okay, alright, and let's get one more over there on the far negative side. Bella, something over here on this side, negative integer value.
-8 and 0.5.
-8 and 0.5. Okay. So -8, 0.5, about right there. Everybody okay with that? And we don't necessarily have to have that many, but in this particular case, the y-intercept I knew, I'd already found this one, so I picked 3 other ones. Alright, everybody okay there? Alright, so Claire, did you get that to work that time?
Yes, ma'am.
Okay, alright, so we're going back to y equals, we're gonna graph the next one. What's this graph gonna look like in general, overall shape? Look at the equation, what's its overall shape?
Is it gonna be a U or is it a?
Yeah, it's gonna be a u because it's x squared, is everybody okay with that? I don't know anything else about it, I just know that. Are we okay there? Yes? Okay, we're gonna finish this tomorrow because I wanna make sure like we're good, okay?